go for introduction. Apply maximum and minimum. Apply maximum and minimum is the process of relating two quantities with their respective rate. Change in one quantity will result in change of another quantity. Involve two or more variables that change at the same time. Writing an equation relating the two variables. Take the derivative of the equation with respect to time. And last, implicit differentiation is usually used. Alright, for problem statement, we have a glass window frame is a form of a rectangle at the bottom and a semicircle at the top. As shown below, it has a perimeter of 4m. So, find the maximum area of the glass window. Now, let's go through the solution step by step. First, we need to understand the problem. We define the variable. X is represent the length of the window and Y is represent the width. And we are given that the perimeter is 4 meters. The next step is to draw and label the diagram. Here we have rectangle at the bottom and the semicircle on the top. The width of rectangle, which is X, is the same as the diameter of semicircle. We also label the semicircle radius as R since it will be useful in our calculation later. Labeling the diagram is important because it helps us visualize the problem clearly and ensure that we correctly assign values when forming equation. It also helps prevent mistake in the later step of solving the problem. By labeling each part, we can systematically work through the relationship between variables and solve for unknown efficiently.
Now I will be explaining about step 3, formulas or equation. So from the diagram, we can conclude that radius R is equal to x over 2 or 1 over 2x, and the perimeter of glass window is equal to 2y plus x over 2 pi. And then the total area of glass window or A is equal to area of semicircle plus area of rectangle, and it becomes pi r squared over 2 plus xy. And now we are going into the conditions. From the formulas we have listed just now, we are going to put the perimeter of glass window given in the equation, which is 4 meter, into the perimeter equation. So it becomes 2y plus x over 2 pi equal to 4. But just now, I have said that x over 2 pi can also be 1 over 2 x pi. So, because of that, I plus it with the x, and now it has been simplified and it becomes 2y plus 3 over 2x pi equal to 4. And that's our first condition. Next, we're going to find a value to substitute into the area equation. So here, from the perimeter equation, we are using the value of y in the term of x. Y equal to 4 minus 3 over 2x pi divided by 2. And we simplify it more, so it becomes y equal to 2 minus 3 over 4x pi. So it becomes condition number 3. After that, we are going to put the area of glass window formula as condition number 2, which is A equal to pi x over 2 square pi divided by 2 plus xy. But before that, we can simplify the equation even more. So it becomes 1 over 8x squared pi plus xy. So that it will be easier for the calculation later. After determining all the conditions just now, we're going to substitute condition number 3 into number 2. A equal to 1 over 8x squared pi plus x, and in the bracket is the value of y, which is 2 minus 3 over 4x pi. And after the calculation, the result will be A equal to negative 5 over 8x square pi plus 2x.
For step 4, we need to find x by setting dA over dx equals to 0. The first step we need to do is to differentiate a, which it will become dA over dx equals to negative 5 over 8 x squared plus 2x. And the next thing that we need to do is to set the derivative to 0, which is it will become negative 5 over 8 x squared plus 2x equals to 0. And the next thing that we also need to do is to differentiate it term by term, which this step we also need to apply power rule, which is it will become 2 in brackets negative 5 over 8 x squared, which is 2 will minus with 1 and plus 1 in brackets 2 x 1 minus 1 power 1 minus 1 equals to 0. And this will simplifies to negative 5 over 4x plus 2 equals to 0. And this will solve for x, which is it will become negative 5 over 4x equals to negative 2 and x equals to negative 2 over negative 5 over 4. And the final answer will become x equals to 1.6 meter. Step 5, we need to determine whether the area is at a maximum. We take the second derivative of a. First, we differentiate the first derivative again, which results in negative 5 over 4. And we need to differentiate again to find d square a over dx square, which it will be d square a over dx square equals to negative 5 over 4x plus 2. And the next thing is we need to differentiate it term by term, which is also we need to apply power rule, which is it will become d square a over dx square equals to 1 in brackets negative 5 over 4 x power 1 minus 1 plus 0. And this simplifies to d square a over dx square equals to negative 5 over 4 plus 0 equals to negative 1.25. And since the differentiate just now is less than 0, the area is at a maximum when x equals to 1.6 meter. To find y at the maximum area, we need to use the given equations just now. The first thing first is y equals minus 3 over 2 pi x over 2. And the next thing that we also need to do is to substitute x equals 1.6 meter into the equations, which it will become y equals to 4 minus 3 over 2 in brackets 1.6 pi over 2. And the next thing is we also need to simplify the expressions. It will become y equals to 4 minus 2.4 pi over 2 and y equals to 1.6 pi over 2, and the final answer is y equals to 2.5133 meter.
So last but not least, I will be explaining step 6, which is the last step into our solution. Right after we obtain the value of x, which is 1.6 meters, and the value of y, 2.5133 meters, we will be substituting it to find the total area of the window by using this formula, which is 1 over 8 x squared pi plus x times y. So as you can see, we will be substituting the x values and y values into the formula, and we'll end up with 1 over 8 1.6 square pi plus 1.6 times 2.5133. And then simplifying it even further, 1 over 8 2.56 pi plus 1.6 times 2.5133. And then simplifying it even further, 0.32 pi plus 4.0213. And then at the end we'll end up with 5.0266 meters square. Therefore, the maximum area of the glass window given these dimensions is approximately 5.0266 meters square. So as for the conclusion, by using calculus optimization techniques, we determine the dimensions of the window that maximizes its area given a fixed parameter of 4 meters. This demonstrates the practical application of derivatives in solving real-world problems involving maximizing and minimizing quantities. So that is it from us. Thank you for your time, and yeah.